Jonathan Drori. I'm Rebecca. I'm from Sheffield Rotherham Trust. If everyone can just put themselves on mute, that would be fab. Just really helps. So we're thrilled to have Jonathan with us this evening. I know there's been a lot of requests for talks about botany, so we're really, really pleased to have him with us this evening. So just a couple of housekeeping bits just again before we get started. If you can all pop your microphones on mute. The session is being recorded, so if you don't want to appear on film anywhere, then just switch them off. The recording's only going to be shared with other people who have signed up, but who couldn't attend this evening. But if you don't want to be on camera, then just turn the camera off now. You can pop chat questions in the chat box as we go along, and then we'll put them to John at the end of the talk. Or you can ask him questions at the end as well, whichever you prefer. But we'd just like to say thank you so much to Jonathan for hosting this Wild Night in with us. As you probably know, Jonathan is a best-selling author. He's a documentary filmmaker, trustee of the Eden Project, amongst many, many other accolades that I just don't have enough time to mention. But this evening, he'll be talking about his book, Around the World in 80 Plants, which is a botanical journey of beauty and botany, myth and mayhem. And yeah, just a massive thank you so much once again for coming. And I will hand over to Jonathan now.
Thank you, Rebecca. Just stay unmuted for a minute because I'm going to try and set everything up at this end and make sure that I can share the screen and all that. And once you tell me that it's all working, then we're all good.
Yeah.
So let me do that. Let me do that, and you should be able to see a picture of Sheffield, and you should be able to see my little laser pointer.
Yes.
That's all working, is it?
Yeah. If everyone's okay, anyone in the chat, just give us a thumbs up on camera. Yes. I think we're good to go.
You.
Yes, all looking good. Everyone's, lots of positive reactions there.
All right. Well, look, thank you so much for having me. Thank you for the work that you do in the Wildlife Trust. Super, super important. And everyone I ever meet at wildlife trusts around the country are just the loveliest people. We'll have a group hug at the end, a virtual one. So the plan for today is that I'm going to talk for about 45 minutes. If it gets dull, Rebecca, just interrupt and stop me. Ask me some questions, claim that there's some technical fault or something, and then we can just move on to that. And I'll I'll talk a bit. I might read a bit from a couple of the books just to split things up a bit and show you some pictures that the artist Lucille Clerc has done. But essentially, this is a kind of botanical tour. So here's where my botanical tour started. That is me, aged about 6 or 7, I think, with my dad at the Royal Botanic Gardens in Kew. That's the palm house in the background. And you can tell that my dad is a sort of first-generation immigrant to the country because he's wearing a suit in order to go to Kew Gardens on a Saturday afternoon. But his first love was botany. He retrained in engineering, but his first love was botany. And my mum's first love was also botany, but from a sort of aesthetic point of view, and his was from a scientific point of view. And to keep my brother and me jollied along, they used to feed us bits of plants that we saw. And I remember having a lick of an opium poppy, which was quite an interesting experience. The physical experience of licking an opium poppy wasn't that special. It just makes your tongue go ever so slightly numb, almost like it's got a little tiny piece of ice on it, and that's all. The effect on my teacher when I told her was much bigger, and they sent round a social worker to see that I wasn't being abused. And you can imagine what would happen these days, but they just all shrugged it off. And my parents used to tell us stories about all these plants in order to keep us interested. And one of the plants they told us about was Diffenbachia, which should be coming up on your screen now, which is you probably know it as dumb canes if you have any North American roots. It's poisonous. It comes with a do not feed to your child warning, keep pets away from it. And if you put a tiny, tiny bit in your mouth, as my dad encouraged me to do, you get this sort of very stinging sensation. And if you take a bite of it, which I didn't, it makes your throat swell up and it stops you from talking. And this was the way that my father broached the very difficult subject at probably about 10 or 11 years old of slavery. This was a plant that was a punishment plant that was given to enslaved people by slave owners in the American Deep South at the time of slavery. And he sort of broached that subject through this interesting plant, which has this poison that it has evolved with in order to protect itself. So all these stories that I started learning about plants were really things that plants have evolved with for their own good purposes, which of course human beings have put to other uses. I had an amazing opportunity to travel and see the incredible diversity of plants, and I sort of caught the love of plants through that travel. And I was working as a documentary filmmaker with the BBC for a while, and actually that enabled me to have a lifelong interest in tropical medicine as well, because I caught some interesting diseases along the way. But that's for another night, perhaps. But incredible diversity. I don't know if you can see that, the size of that person standing by these ludicrous wax palms in Colombia. It's just ridiculous. And here's a quiver tree, which we might come back to later. Incredible diversity, incredible. There are about 400,000 species of flowering plants, all evolved to fill different environmental niches. All with incredible, interesting relationships with all sorts of other organisms. About 40% of these plants, or 2 out of every 5, in other words, are at risk of extinction because of the things that human beings like you and me get up to, which is sad. And they all have such wonderful stories. And part of my reason for telling stories, and part of, I think, your reason for telling stories to people about what you do, is to, with the thought that if people understand, they'll start to care. This is a plant that you're probably very familiar with, woody nightshade, member of the feisty solanum family, and we'll come back to the solanums a bit later. And just among the trees, there are 60,000 species, all evolved to fill their particular niche. And one of the things that I started thinking about when I was communicating about plants was, if we think about humans and the kind of things we need, well, maybe it's not too much of an anthropomorphic stretch to think about some of the things that trees need in the same sort of way, trees and plants. So let me start you with a question, which is obviously in this case a rhetorical question, so you just need to answer it to yourself. But a little seed weighs next to nothing, and a tree obviously weighs a lot. So where does all the stuff come from to make, for example, a log, or in this case, a bag of charcoal? Where does the mass come from? And if you ask people, as I have done in many contexts, you find that about 85% of people say that it comes from nutrients in the soil. And I don't know how it is in Sheffield and Rotherham, but where I live, we don't have trucks driving around all night, sort of filling in all the soil that somehow the plants and trees have taken out. And if you have a pot plant, then you'll know that it just sort of grows and grows without having to top up the soil. And you might have to add a few drops of baby bio once in a blue moon. But the weight of the thing isn't coming from a few drops of baby bio. It has to be coming from somewhere else. And this actually is the miracle of photosynthesis. It's the miracle of photosynthesis that most people, about 85% of the population, don't understand. So when I ask, where does all the stuff come from? The main answer is out of the air. Carbon dioxide from the air, and of course water from the roots. Those are the 2 components that make up the bulk of the weight of a tree or a plant. And the carbon dioxide is a colorless gas, and so people think that it doesn't really sort of weigh very much. But I can tell you that that bag of charcoal that I showed, that all of the weight of that came from the air, because all of the charcoal is just carbon, and the only place that carbon is coming from is from the air. So you know, that's a sort of surprising thing for most people. And some people say, oh well, it comes from sunlight, and but that's like saying that the weight of your dinner comes from the gas that you use to cook it. It doesn't at all. It comes from the ingredients you put in, and the ingredients of photosynthesis are water from the roots and carbon dioxide from the air, and a few other little trace elements, but they don't add much to the weight. So there you are. Other than trace elements, it comes, you know, the bag of charcoal comes out of the air. So if you need any more convincing, here's Spanish moss, or tillandsia. It's not a moss, it's not Spanish. It's a cousin of the pineapple, and it's an epiphyte. That is, it's a plant that grows hanging on trees, or as you can see there, on wires. And in this case, in the American Deep South. It's very gone with the wind. Very appropriate, actually, because this is an epiphyte, survives from the rain and air. There are no roots going into the tree or anything. It's not a parasite. And any extras are just sort of dust and bird droppings and so on. It's very odd, curly stuffing. It was used as stuffing for mattresses and car seats. They look as if they got a bit carried away with that one. And as you can see, growing in midair, no soil needed. Let me read you from Around the World Native Plants. Let me just read you there you are, a little bit about Spanish moss, because it is a wonderful, wonderful plant. And while I read, you can look at some of the drawings that Lucille has made. An eerily iconic plant of the swampy southern states, it has skeletal, finger-length leaves that curl together into chains, forming elongated grey-green curtains that drape from trees and telephone wires. Victorian travellers to the deep south wrote melodramatically of trees that swept the cobwebs from the sky, or appeared to them as witches weeping in the moonlight. It is indeed a strange plant. Spanish moss is also used to stuff hoodoo dolls, charms believed to ward off evil and bring good fortune to oneself, or more rarely, misfortune to another. Hoodoo is a spiritual offshoot of Louisiana voodoo, a system of beliefs that developed in the southern states from the traditions of the West African diaspora transported there in the 18th century. The link with hoodoo talismans contributes to the plant's creepy reputation. But the people who craft those dolls may be playing on more primitive emotions. Perhaps Spanish moss and the swamps it inhabits embody nature untamed, rampant, and beyond our control. That's Spanish moss for you. Now, staying with photosynthesis, here's a plant I'm sure you know. This is mare's tail or horsetail, equisetum. Very abrasive. It contains silicates, sand essentially, which is protection against herbivores, and it's used in Japan for polishing furniture. Is used in this country sometimes still for clarinet reeds and for polishing them. And primitively, these were the ancestors, the ancestors of these plants were the main plants on Earth 360 million years ago. And here's what the ancestors probably looked like. I like to think of them as calamities, but it's actually calamites, massive things, 160 feet high. They didn't rot, but died and got squished and turned into coal. And one of the questions that I always sort of wondered about coal was, we were taught at school that you know, the trees fell over and then didn't rot but were squished. But whenever I see trees in, you know, the heath near here, they fall over and they rot. And so why didn't these trees rot? Some of it didn't rot because they were in swamps and you get the sort of anaerobic conditions, and that means that the bacteria don't live so well, like in peat bogs. But actually, and there is scientific debate about that, what it turns out most probably is that 360 million years ago, bacteria and fungi hadn't yet evolved to be able to break down the sort of woody stuff, the lignin as it's called, in wood. And it took them about another 60 million years to work out how to do that, to evolve to do that. And so all of the world's coal, or pretty much all of the world's coal, was laid down between 360 million and 300 million years ago, when the bacteria and fungi hadn't worked out how to break down the calamites. And eventually they did work out how to do it. And so now when you leave a bit of wood out, it rots and releases the carbon dioxide back into the atmosphere. But with coal and fossil fuels, we have tens of millions of years worth, of energy from sunlight wrapped up in the fossil fuel, which is sort of very useful for the energy. But it's also tens of millions of years worth of carbon dioxide that's been sequestered. And so it's absolutely bonkers for us to go around releasing tens of millions of years worth of carbon dioxide that's been absorbed just in a few human generations. Absolutely mad. And that's one of the arguments against fossil fuel. So nowadays, dead wood rots, carbon dioxide goes back into the atmosphere. So building wooden frame buildings is a great idea, so long as it comes from the right source, right species, right place, and so on. And so, of course, is reading and buying books, because I would say that, wouldn't I? Because obviously they're made out of, predominantly made out of carbon. So that's a terrific thing to sequester and put on your shelf. Water is absolutely vital to plants, not just for ferrying stuff around or for keeping everything kind of rigid. Remember, it's also one of the vital ingredients for photosynthesis. So plants will go to any lengths at all to get water. And this plant, the moojar, as it's known in Aboriginal language, or the Western Australian Christmas tree, as people dubbed it when they went over there, has a dirty little secret when it comes to water. Look how it's absolutely sort of bursting with life, even in a dry environment. And moojar's dirty little secret is that it's like mistletoe. In fact, it's a member of the mistletoe family. Is a parasite. It draws water and nutrients from other plants. Now, technically, it's a hemiparasite. You can see that it's got green leaves, so it is doing some photosynthesizing of its own. But what it does is it sends its roots 80 yards or more, and it attaches a collar. I don't know if you can see that, a sort of collar, donut-shaped collar around the host root. And then it whips out its pair of hydraulic secateurs, seen through a microscope here, and cuts the host root and plugs itself in to get the water and also some nutrients and so on. And what I particularly love about this story is that the way that the moojar root sniffs out the host is through a sort of molecular trail of plant hormones. And those plant hormones are also present in plastics, or some plastics. And it's particularly present in some of the plastics that are used to insulate wires. And you can see where I'm going with this. This plant, moojar, will seek out and sever underground telephone wires. And I love the fact that it does this. And it's a sort of like the plant community fighting back against humankind. A slightly mad thing, but it does it. And finally, with photosynthesis, here's another one of Lucille Clerc's gorgeous illustrations. And in case you thought that photosynthesis is something that only happens on land, I just wanted to read you this. Microscopic single-celled organisms may not fit everyone's definition of a plant, but a plant's most important capability is to photosynthesize, and phytoplankton certainly do that. Most of them live for just a few days drifting on ocean currents, suspended near the surface where there's light. Using sunshine to power the process, phytoplankton consume carbon dioxide dissolved in seawater and incorporate carbon compounds into their tiny bodies, just as carbon is stored by the wood and leaves of a tree. They may be small, but they're abundant. A tablespoon of seawater may contain hundreds of thousands of individuals. Together, the world's marine phytoplankton absorb as much carbon dioxide and give off as much oxygen as all the trees and every other land plant combined. They're also the ocean's primary producers, the first link in the food chain. Without them, hardly any other sea life would be possible. Phytoplankton are typically the width of a fine hair, but can be much smaller. Magnification reveals a parallel universe of intricate structures, the stuff of acid dreams. Solitary spaceships and implausibly geometric shapes, minute snakes and ladders, and garlands of elaborate beads on infinitesimal threads. There are thousands of different species. I love the idea of something being kind of, hidden in plain sight, although you need an electron microscope to see them. So we've talked about what plants eat, and now I'd like to talk about defense, because obviously plants and trees are largely rooted to the spot. So to an insect or any other herbivore, this lovely scene, probably looks like lunch. And it's amazing to me that trees, for example, survive at all, because a tree which might grow for hundreds of years is thousands of life cycles of insects and the things that would eat them, thousands of life cycles of evolution in that time, and bacteria and viruses, many, many more. You'd think they'd get around the tree's defenses. But trees have a huge library of genetic information, extra defenses that can be deployed when things get tricky. All sorts of ploys they have. Those defenses have led to very, very interesting relationships with human beings. So tree defenses are many and varied, and you have things which are very, very spiny. You have oak trees, for example, that contain tannin in the bark that disrupts the digestive system of herbivores. You've got things, two-part poisons, which is a concept the military use in things like cherry laurel. You've got coffee, caffeine, which contains chemicals which are called allelopathic chemicals, which put off, it doesn't really sort of put off insects that much, a bit. It's a little bit poisonous, but it really puts off other plants from germinating nearby. Walnuts do the same, by the way. Don't try growing tomatoes under your walnut tree. Manchineel, every part of that plant is horribly poisonous. And then there's this. You might think that I've shown this picture because I don't know, the little droplets of sap there are kind of poisonous or something. But no, they actually attract insects. And what they do is they attract the insects that eat the insects that are eating the plant. Lots and lots of clever ploys that plants have to defend themselves. Now here's mandrake, which has some very clever ploys to defend itself. This is representing Italy in the book. Mandrake is a real plant. It's not a mythical one, not just Harry Potter and Hogwarts. Notice these flowers. What are they like? They, as you can see, they're very much like the plants I pointed out earlier on, the solanums. And this is another member of the feisty solanum clan, used since ancient times as an anesthetic. Often it was added to wine. And it has a lot of occult associations, partly because the root often looked like a person, I have to say, possibly with a bit of judicious whittling. And the story went that the scream of the mandrake could be deadly, so tie a dog to the root and then kick the dog. And you see this old drawing from medieval times. So tie a dog to the root and have the dog pull it out. And I can't help thinking that these might have been rumors, actually, to stop people stealing such an incredibly valuable plant, because anesthetics were in very short supply. And very important drug, so people would have wanted them not to steal them, so they'd probably put that rumor about. Let me just read you a little bit about the mandrake. It's a slightly adult story, really. I've tried to be sort of circumspect about the language in case there are children around. Several 14th and 15th century accounts describe witches' salves made from mandrake and other psychoactive plants pounded together with grease. Such ointments hasten the absorption of the hallucinogenic drugs in mandrake through the skin and especially through the body's mucous membranes. One substance, hyoscine, is known often to impart a convincing sensation of flying, which plausibly explains why so many medieval woodcuts depict nude or partially clothed witches, airborne and straddling broomsticks, an idea that still has common currency. Although mandrake's use as an anaesthetic ended with the introduction of ether and chloroform in the mid-19th century, some of its other ancient associations live on. In the 1930s, one of the first comic book superheroes was Mandrake the Magician, and in the 1960s, a sedative pill called Mandrax, among many chemically similar products, was the one brand that became associated with promiscuous sex. And today, at least one commercial fragrance uses the name Mandragora, the Latin name of mandrake, to simultaneously conjure helpless abandon and beguiling agency, just as it has for millennia. Interestingly, I was on I took a ferry recently to Northern Ireland, and someone offered me a seasick tablet, which I actually didn't need. But when I looked at the label, I noticed that it contained hyoscine, which is, so I suppose if you take too many of those seasick tablets, you'll start to feel like you're flying. Might be easier to take mandrake. No, don't. I'm trying to change the slide and nothing's happening. Sorry. There we go. Here's another means of defense that plants have evolved with. This is gutta-percha. So you know about rubber and latex. This is a plant with another kind of latex, a plant from Borneo and Malaysia. The purpose of latex in plants is to kind of seal wounds, gum up the mouth parts of insects and so on, stop infection. And you know, you slash the bark and you get the latex. This is a slightly interesting story, more interesting, I think, story than you'd expect, though. In 1840, this is one of the slightly uncomfortable-looking colonial engravings of the time. There was a Scottish military doctor in Singapore, saw indigenous people using a rubber-like material, not as stretchy as rubber, but moldable in hot water. And then when you took it out of the hot water, it would set. So hurrah, a natural thermoplastic. And locals used it for making galoshes and tool handles and things like that. But this doctor sent it to London, and the gutta-percha company was born. And first of all, they made these sort of exciting kitchenware things, any color you like, as long as it's black. And lots of entrepreneurs set up with companies doing gutta-percha-y things. And then someone worked out that you could make golf balls out of this material. And whereas previously they'd been made out of feathers and all sorts. And suddenly the game of golf took off. But you know, there's something even more important than that. They started making horse booties out of them so that you could have a horse drag your lawnmower without churning up the soil. And they were called frog covers. Horse-drawn lawnmowers, you know, were suddenly all the rage. But there is something even more important than all of this. And the thing that's more important than all of this is that people worked out that gutta-percha was the one material that they discovered by the sort of 1890s or so, with which you could insulate cables that would go underwater. So a waterproof insulation for cables. Why is this important? So that people can talk to each other on the telephone. By 1910, in all sorts of swashbuckling escapades around the world, people had laid out 250,000 miles of gutta-percha insulated cable just so that people could talk to each other and send messages and information around the world. That's one of the early maps of where the first cabling went, gutta-percha insulated. And you can see it all starts from the British Empire. Malaysia in 2018, this is a contemporary stamp. There's a picture of, you know, on a mainstream postage stamp of an insulated cable, which was so important. Gutta-percha changed the world. And the only thing that gutta-percha is used for now is for filling teeth after root canal work. And all of this from a plant's defense mechanism. Here's another defense mechanism for a plant. This is the Japanese lacquer tree, its defense is urushiol, which is a really horrible chemical. It's the same sort of stuff in poison ivy, in its sap. But it enabled people hundreds and hundreds of years ago to make very, very beautiful lacquered material. And you have to imagine lacquered lacquerware, you know, sort of lacquered bowls and so on. And you have to imagine a world before plastics, because this is a polymer material, natural polymer, which is like a plastic essentially. You have to imagine a world before plastics, being able to have something that was not only beautiful but also completely impervious to water, and wouldn't rot. An amazing substance. And there's a picture from the book of the rather beautiful plant. Creepily, there was a phase when ascetic northern Japanese monks used to consume this material, this sap, and sort of a kind of tea made out of it and embalm themselves while they're still alive. It was rather creepy. And when they eventually died, their bodies were so sort of full of this plasticizer that they wouldn't rot. And so when they were dug up after a period, and they hadn't rotted, that was a sort of path to Buddhahood. If you go to Japan, actually there are some of these preserved mummified bodies still around. Sweet dreams, everyone. And another plant with a very nice way of defending itself and a nice story behind it is the alder. So I know that you will be very familiar with this in nice, wet, rainy Sheffield. This is a plant that has very good defenses against rot. It grows by the waterside, partly because of that defense against rot, and partly because it needs to find a way of getting nitrogen from the soil, and has a sort of a symbiotic relationship with bacteria that live in the nodules in the alder roots. And so in waterlogged places where plants can't quite get the nitrogen they need, you find these sort of relationships, and it has that. But that has made it very, very good for making things that are going to be immersed in water. And so people in the Low Countries make clogs out of it. And in Venice, the Ponte Vecchio and much of Venice is actually built on alderwood piles. Now, the thing about alderwood is that it not only makes really good piles for building absolutely brilliant buildings on in the middle of a lagoon, but it also makes excellent gunpowder. In fact, the British Army, I don't know why they still use gunpowder, maybe for making fireworks, but they specify alderwood, alderwood charcoal. And the other thing that you can do if you've got alderwood charcoal is that, and you're a Venetian in the 14th century, is that it means you can smelt steel. And if you can smelt steel, then you can make weapons. And if you've got gunpowder, you've got something to go in those weapons. And so the Venetians managed to convey and project their power across the Mediterranean in the 14th century. They were the power in the Mediterranean, and they projected that power through the architecture based on alderwood piles, through gunpowder and steel, that was smelted in a place called the Ghetto, actually, which meant forge at the time. That was the source of their power. And the Venetians built their warships out of other woods that were very, very strategically protected and so on. And at the height of their power, the Venetians could build and kit out with all the weaponry and everything one ocean-going warship a day, one a day. I mean, absolutely astonishing. And they did that at a big production line at a building called the Arsenale, which has given us the word arsenal. Absolutely astonishing feat of engineering and organization, all based on trees' ability to defend themselves. Fantastic. And here's the beech tree. I particularly like the beech associated with writing in every European language. The beech and book have very similar words. In German, Buch and Bücher. A book had vellum pages held together by beech boards. In German, alphabet letters to this day are called Buchstaben, the marks carved into beech. Rembrandt used beech galls for ink. Medieval writing desks were made from ink, were made from beech. The first experiments with movable type were beech wood. And the smoothness lends itself to being used as a kind of writing medium in itself, which I'm sure must irritate you in the Wildlife Trust, because you know, you don't really want people carving stuff on trees. But that smoothness, because the outside of the tree doesn't, it sort of constantly sloughs off rather than building up, you know, cragginess. All sorts of people have written on trees, including Virgil, the Roman poet, who complained about people writing on trees and then did it himself. But why have I included this in the piece about, in my sort of section on defense? And the reason I've done that is because in Germany, people have, there's a folk saying, which is beeches are never struck by lightning. Lightning never strikes a beech tree. And it turns out that beech trees are struck by lightning just as much as any other trees growing in a similar place of similar size. So why do the Germans have that saying? And the thing is that beech trees, while they are struck just as much as other trees, they survive. And why is it that beech trees survive much, much better than other trees if they're struck by lightning? The reason is that if you imagine, obviously, when there's lightning, it's a storm. And when there's storm, it's raining. And when the outside of a beech tree gets wet, all of it is wet. The outside of an oak tree with all its little crags means that there isn't an uninterrupted film of water. So for the beech tree, that film of water acts as a lightning conductor. When lightning hits the top of the tree, the electricity flows harmlessly down the outside of the tree and into the earth. Whereas when lightning hits an oak tree, it's much more likely to not be able to travel down the outside because bits of the conductor are interrupted. It'll travel down the inside of the tree and blow it apart. So beech trees survive more frequently. I love that. So having survived, trees need to make more trees. And there are some trees that do this quickly and easily with suckers. Aspens do that. You'll know other trees that do that. The trouble with that is that all the trees in this picture are identical twins, and that means that they'll be very vulnerable to disease. Fortunately for aspens, the different clumps around the world are of different genetic makeup, but all the ones in one group are similar makeup, and that makes them vulnerable, just in the way that the elm trees have been so vulnerable because they largely propagate through suckering. I mean, they can through seeds, but they largely propagate that way. So they've been very vulnerable. So a better way is to have sex. And the way that plants have sex is, there are different ways, but a common way is through flowers. And flowers have pollen, and pollen carries the male sex cells. And you need to get those male sex cells to the female parts of another flower somewhere. And the way that a lot of plants do this is by throwing their pollen to the wind. And off it goes, and you just hope that this thing that is about a 50th of a millimeter across lands in just the right spot. And obviously that means you have to make an awful lot of it, and it's very wasteful, but there you go. Surely that you'd think there's a better way. And indeed, the way that flowering plants have evolved is to commandeer something else to, in this case, a bee, in exchange for some sweet nectar, take the pollen exactly where it needs to go on another plant. But there's a payment for that. So you don't need to make so much pollen, but you do need to make sweet nectar. And that is an energy intensive, costly process for the plant. And sometimes plants help the insects along and help themselves at the same time. You can see these florets of horse chestnut. Some of them have changed color. And insects don't see red very well, so that those red ones have sort of disappeared, and they're more likely to see something like this and concentrate on the yellow ones where there's still pollen to take away and nectar nectar that's available. So the plant has told the bee, I've already been visited when it's visited, changes from red to changes from yellow to red and disappears, so that the insects don't have to spend so much time, and the horse chestnut doesn't have to spend so much effort making more nectar that isn't going to be used. I did say that most insects don't see red very well. So why do we have red flowers on things? Well, sometimes it's because we've bred them to be red, but in the things that are naturally red, they're unlikely to be pollinated by insects, more likely by butterflies, which are insects, of course, but less likely to be flies or particularly bees or wasps, more likely to be butterflies or birds. And then you have some plants like the durian, well known in Malaysia for being incredibly smelly, and in fact, Anthony Bourdain, the famous chef, described the scent as being like French kissing your dead grandmother, which is obviously in poor taste, but actually it is quite a difficult taste of fruit. And that is a plant that has these wonderful blousy big flowers that smell a little of sour milk, and they come out at night. So can you guess what would pollinate that? Yep, it's a bat. I don't know if you can see batty back face just there. And they get covered in that stuff, and there's absolutely gallons of nectar that bats drink up. So having pollinated, trees need to spread their seed, because that is the next generation, and those need to be dispersed so as not to compete with the parent tree. So this is why fruits are laxative. Fruits are laxative because you want something to gobble up that fig in this case, or the fruit, but you don't want the seeds to remain in the intestines for too long. You want them to be pooed out somewhere before too long, because it's not a very nice environment inside an animal's gut. You want them to be pooed out with a little pile of fertilizer, and so all fruits basically are laxative for that reason, and they get dispersed that way nice and efficiently. And you find that fruits are generally sweet, and they're particularly sweet when they're ripe, and in other words, when the seeds are ready to be dispersed. And the seeds themselves are often either poisonous or very, very bitter. So, for example, apple seeds are both poisonous and very bitter. And I'm sure you can think of other ones that aren't really very good to eat. And the ones that we have got to eat from fruits tend to be ones that we've bred that way. Here's kapok, a plant that throws itself to the wind, a way to get itself away from the mother tree and carries far and far. Hazel trees manage to persuade very forgetful critters to come and bury their seeds and then forget where they put them. Coconuts drift on the water, and the wonderful coco de mer from the Seychelles. As you can imagine, this was seen as an aphrodisiac, and was very, very expensive for hundreds of years when sailors found them. Only royalty could buy them for a period. These are so heavy, they're not distributed by water. This thing is the size of a sort of carry-on luggage kind of thing, 20 kilos. And the way that it doesn't compete with the mother tree is that it lands and then, or sort of plummets, and then sends out an umbilical cord and germinates actually about 12 meters away. Here's another interesting kind of way of dispersing seeds. This is the sandbox tree. I took this picture in Madagascar. It's actually a native of Costa Rica. Grows to about 160 feet high. Dense forest, not much light. The seeds need substantial kind of need to be flung out a long way, and the forces that build up in these tangerine-looking kind of seed cases are very, very big, because bits of them dry out faster than other bits. And when these things go pop, it sounds like gunfire. I mean, it's absolutely a huge bang. The seeds, which are like little miniature frisbees about the size of a pound coin, they come out at 150 miles an hour, and they'll go about 150 feet. There was a German naturalist in the 19th century who put one of these things in a glass. He got one and put it in a glass bell jar. And luckily, he went out for lunch, because when he came back, the bits of glass embedded in all the walls. Huge amount of energy stored up through these stresses built up through dehydration. It's called the sandbox tree because when it's defused, if you like, and sort of cut in half, people use them, Victorian letter writers use them for blotting sand. And blackberries, for example, distributed by birds, these show up very well against autumn colours in bird vision. So infrared and red colours, very well for birds. And my last plant, the nutmeg, absolutely lovely little tree. When its fruit are ripe, they split. The seed has a bright red aril, seed covering aril. This is a sort of slightly bigger than ours pigeon, rather bigger. It's called the nutmeg pigeon, and it swallows these and poos them out in the way I described. And these nutmegs were native to what is a small area of what is now Indonesia. It reached Europe in about the 13th century, and Arab traders kept secret their source for centuries. It's very expensive, very, very desirable. It enlivens boring food, but it was also used as an amulet. So Leonardo da Vinci in 1510, from his to-do list for his trip to Padua, he had spectacles with case, penknife, sheets of paper, scalpel, acquire a skull, nutmeg. That was his to-do list. Very, very important thing to have. And European wars over the nutmeg trade between the Dutch, the British, the French proceeded throughout the sort of Middle Ages. And eventually in 1667, the British finally gave up their claim to the main source of nutmeg in what is now Indonesia, in exchange for a hopeless little Dutch outpost in North America. And that was a little outpost called Manhattan. So Manhattan was traded for monopoly nutmeg rights. By the 18th century, nutmegs still weren't just about flavour. They were also rumoured to spice up physical desire and performance. So nutmeg was the kind of Viagra of the day. And European gentlemen carried little pocket nutmeg graters, meaning the sky was, the price was sky high for this thing. You see the little compartment there that would store the nutmeg. And Malcolm X, the Black American activist in prison, he used nutmeg to try and get high, which as students we all tried as well. It's terrible. It makes you throw up. It's horrible. But when he wrote about this in his autobiography, nutmeg was subsequently banned in all American prison kitchens. So I started with Spanish moss, and I'll finish with its close relative, the pineapple. And it was so rare and expensive in the 18th century that people used to rent them out as little accessories to take to parties, like people with chihuahuas, I guess, in little bags in Beverly Hills. And it entered the language to stand for anything really, really great. A pineapple of a gentleman. That party was quite the pineapple. And Charles Lamb wrote, and I've got the quote here, "Pineapple is too ravishing for mortal taste. She woundeth and excoriateth the lips that approach her, like lovers' kisses she biteth. She is a pleasure bordering on pain from the fierceness and insanity of her relish." Maybe it wasn't ripe, or maybe it says more about about Charles Lamb than it does about pineapples. Anyway, there he is. So water, carbon dioxide, defense, and the ability to make more trees. What else do trees need? They need stable ecosystems where all the little critters that will pollinate and disperse the seeds can all thrive. And that's what, of course, wildlife trusts are all about. Above all, trees and nature in general need some love. And with that, I'll finish. So thank you for listening to me. I'll answer some questions now if there are any. It's very strange talking to a screen. I hope it's been all right. And I'll stop sharing my screen. And if you want to get in touch with me, that's my email address. So let me just stop this. There we go.
Thank you so much, Jonathan. That was absolutely fascinating, like completely fascinating. And I'm sure everyone else is thinking the same thing as well.
Thank you.
We have had a couple of questions already in the chat box. So I'll just go ahead, and I think there's some more coming in now. So the first one, which I'm sure is a tricky one, is, in your opinion, what is the most important plant?
Oh, gosh. I don't know. Because the thing about an ecosystem is that it's a system, not just one. So, you know, the thing about plants, as opposed to animals, is that only plants can photosynthesize. That means that only plants can take the sort of basic building blocks of really simple stuff, water, carbon dioxide, and a bit of baby bio, and turn it into things which are really kind of complicated and special. Animals don't do that. What animals do is they take plants or something else that has eaten a plant and break them down. And so all plants as a system are kind of incredibly important. You know, to pick one is really difficult. You might pick the grasses as a family because they give us all our cereals. You know, everything from kind of wheat and rye to bamboo and you know all the other things. But you know, I could pick favorites, but to say one is, you know, more important, I'm afraid I can't answer that.
Thank you. The next question is, do you think urban greening, for example, green walls, are a good idea?
Well, I certainly think that trees in cities are terrific. And you know, here I am talking to Sheffield. Irony not lost. But the you know, I'm talking to people who understand plants. You know, so trees in cities are great. They reduce the temperature, they increase biodiversity, they increase house prices. So in many ways, trees are a good thing. Plants are great in cities because they make people happier. It's been, you know, lots of really good research about what happens in your bloodstream if you are in and around plants, and it's good stuff, right? And it increases biodiversity, and you know, it's you know, good in lots of ways, right? Sort of absorbing carbon, putting out oxygen, you know, good for all the little critters. That's fantastic. So if people haven't got gardens, then window boxes. If you have people gardening out in their streets, that, you know, even if it's just a window box, that increases the sort of communication within the community. So that's another great reason for planting things, and that everyone should be involved. So those are all good. Green walls. I think there's less data on the you know, how cost effective and worthwhile green walls are. So they're great in some places, and in other places they might take a lot of resource to put up, and it might be better you know, to sort of think about just planting trees and window boxes first. But one of the things that green walls do, of course, is they make people look at plants, and that's a good thing, both from a health point of view and also politically, because it means that if people look at plants, they might care about them. So there you go.
Brilliant. Is there a plant adaptation that you're surprised you haven't seen or heard of?
Oh, well, if I haven't seen or heard of it, then I wouldn't know about it. So
It's a trick question. It's a trick.
yeah. What I will do, because I've learned from politicians, is that I'd say that's a very interesting question, and let me answer this completely different one, which is, I just saw flying by there, someone mentioned about fungi. And I think that the relationship between plants and fungi is really interesting in two ways, at least two ways. So I mentioned that the main things that add to the weight of a plant are water and carbon dioxide, and that's absolutely true. But we all know that, plants need some other stuff, and they get that from the soil. And the way they get that is often by forming a relationship with fungi that have much, much finer filaments that are able to spread out much further and have a sort of chemical capability to absorb things, particularly trace elements from the soil, much more efficiently than tree roots do. And so these symbiotic fungi, mycorrhizae, they're called, a fantastic word for Scrabble if you ever get the letters. They enable the tree to get much more from the soil than they would otherwise, and other plants, not just trees. And in return, the fungi get something good as well, which is that they get the sugars from the tree, which is busy photosynthesizing and can make sugars. So the fungi gets a good deal and the tree gets a good deal. And that's that's one of the sort of key ways that in terms of tree nutrition, tree and plant nutrition that's important. So that's one of the great uses of fungi. The other one, fungi have a role in sort of connecting forests and plants kind of with each other a bit. Now, there's been a book that you might have seen called Finding the Mother Tree by Suzanne Simard, who is an academic at British Columbia, a scientist who comes from a family of loggers, incidentally. And she did interesting experiments to show that there's signaling that happens between trees and plants when they're under attack. And some of those signals can travel through the fungal network as well as through the air. So it's not necessarily intentional that I'm sending as a tree to this other tree, but there's a sort of a chemical gets wafted around and it has this effect on the tree. And along with that, some of the components of photosynthesis, some of the sugars can get sent along these fungal networks. Now, there is right up to the minute debate. So Nature, which is the sort of one of the premier scientific journals, had just about 3 weeks ago a big article about just how much of this is really going on or not going on. So there's a lot of debate, but at least some of this is true about fungal networks, and some people call it the wood wide web and so on. Which and it is one of these things that people really, really want to believe, and it would be nice if it was all true, but it's probably sort of partly true.
Thank you for that. That's really, really interesting. And then we've got another question. Have you suffered any mishaps caused by plant defense mechanisms?
Oh my gosh, yes. Have I had mishaps? Yeah, so hey, look, there's probably drug experiences that we've all had, right? And when you're a student, and I'm not condoning, and obviously, but we've all tried them, right? And most of those drugs, I think all of the ones that I ever tried were from plants one way or another, and I should think I had mishaps some of the time. I should think we've had alcohol mishaps, haven't we? And that I might remind you is a plant product. Then I've been in the southwest of Madagascar, in the spiny forest. You can tell the rest of that story before I even tell it. That was a sort of bloody experience. There's every kind of suffering that I think I've had at the hands of plants one way or another. Yeah, definitely.
I'd love to hear more of those stories. I think, has anybody else got any questions? I think
I'll tell you, I just want to share a question that a 9-year-old girl asked recently, and I'm just going to share back just for a second my presentation, just for a moment. Can you see that?
Yes.
Yeah, so that there is in Namibia, and I'm actually goofing around quite close to the camera, and the tree is quite a long way back, so it looks like I'm right next to it, but actually I'm not, and that shadow isn't my foot. So I'm quite, and so this thing is about 50 feet high, that tree. And it's an aloe-dendron, which is related to the aloe that you use in cosmetics. And a girl asked me, if I was a tree, what tree would I be? Now, technically, if you're a real pedant, this isn't a tree because it hasn't got the same sort of woody stem as a real tree has. But to me, it looks like a tree, and that's good enough. And the reason that if I was a tree, this is the tree I'd like to be, is not because it's surviving in this incredibly harsh desert and thriving, and in the right season, it's got bright yellow flowers and it's beautiful. And it's not because it's called the quiver tree because the San people, the local indigenous people, use it for putting arrows in when limbs drop off. That's a nice story. But for two other reasons. One is that it's the national tree of Namibia. So when anyone sees it, they're smiling. And I kind of love that about it. It's a bit like driving a Morris Minor. And then the other reason that I love it is that it doesn't really show up in this picture, but it's got this kind of white, powdery, waxy coating, which is probably to defend itself from the very harsh ultraviolet light. But the reason I love it is because when people come to it, they want to touch it. And so the idea of being a tree that people want to touch and smile at, I think that would be the tree that I'd like to be.
That's brilliant. I love that. And I love your answer. And I think it's a great icebreaker for any more meetings that I have. Does anyone else have any questions they'd like to ask? Great.
Well, thank you for having me. And I really wanted to just thank you again for the work you do. I mean, the Dorset Wildlife Trusts are really important. And whether you work for the trust or you support the trust, if you've tuned in as someone who might donate, then please do. Sheffield and Rotherham Wildlife Trust. And if you work for the trust, thank you. Because the wildlife trusts are just fantastic organisations.
Thank you so much. That's really, really nice of you. And thank you so much for joining us this evening. It's been fascinating, really incredible. Just noticing something in the chat. Actually, I have a quick question. Which book should I read first?
It doesn't matter. They both stand alone. They both stand alone. And all the proceeds that I get from the books from the UK go to environmental charities, by the way. So I can encourage you to read them without feeling awkward.
That's brilliant. So everyone go and get a book,
Yeah.
either of them. That's brilliant. Thank you so much again, Jonathan. It's been amazing. So
thank you. A real pleasure. Rebecca, thank you for asking me to do this. Cheers.
Thank you for coming. Thank you so much. Take
Bye,
care.
everyone. Group
Thank
hug.
you, everyone.
I love you all. Bye-bye.